Hello everybody, this is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. I joined here today with you all in this video or video lecture series for the course Measurements and Instrumentation Engineering. Measurements and Instrument is a course for secondary EEE students, and in this lecture series video, we have been discussing various concepts of comparative methods of measurement in unit number 2 for the course Measurements and Instrumentation. The previous topics we have been discussing about the various DC potentiometers and DC bridges. And in this topic, we are going to discuss about the AC bridges. In the last video, we discussed about the AC bridge classification, which is called as the Maxwell's bridge. And this video, we are going to see about the Anderson's bridge, which is also an important method of measurement, a precise measurement. Come, let's get into the topic. And we are going to see the recap. The bridges and various bridges and measurement. We have seen about the different measurement techniques, the general principles behind measurement, and AC bridges. In AC bridges, we have just discussed about the various Maxwell's bridge, and now we are going to discuss about the Anderson's bridge. So, just understanding the concepts of what you call as the bridges. We have 6 major bridges for different categories. That's the empathy part. The Maxwell bridge is used for the inductance measurement. Mains bridge is used for the frequency measurement. Hay bridges is used for the high Q inductor measurement. And Anderson's bridge is used for the self-inductance measurement. Why the use of an Anderson's bridge? What is the empathy part of an Anderson's bridge? Why we need to study about Anderson's bridge? Anderson's bridge is used for finding out the self-inductance with series resistance measurement. It is one type of a precise measurement technique compared to all the other types. Precision inductor manufacturing, problem-solving innovation, and aerospace defense applications are one of the important parts of an Anderson's bridge. The basic configuration of the Anderson's bridge is shown in the figure. Similar to that of other bridges, it has 4 limbs, and extra we have one limb connected to the central detection and capacitor. You could see in the limb 1, between X and W, we have R1, I1 and Lx, inductance and capacity, unknown resistance, and R3, I1 and XY. IC is the current flowing through the deflection, and C3 is the capacitance, R4 is the resistance, and R2 is another resistance. We have the supply voltage, and the various voltage across each limb is given as E1, E2, E3, and E4. So Anderson's bridge is nothing but the modified Maxwell's bridge by adding series resistance with unknown inductance. The circuit elements you can see here, R1, R2, R3, and R4 are the 4 resistances in the full arms. C is the standard capacitor, and L plus R is the unknown inductor plus resistance. So this shows the diamond configuration with AC source voltage through the galvanometer. After seeing the basic components, we are going to see about the Anderson's bridge working principle. As we all know, the working principle is nothing but the measurement of self-inductance with series resistance. 4 arms which we have to show a null deflection to the galvanometer. Standard capacitor determines the inductance value. So we are going to measure the unknown value of the capacitor and the inductor, and self-inductance is going to be measured, an AC measurement. So it is called as an AC bridge. So here again, the bridge balance condition is going to be the opposite bridges. Z1, Z4 is equal to Z2, Z3. Based on that, we have some equations. We derive the expression for the unknown value of inductance, where L1 is equal to C into R3 into R into 1 plus R2 by R4 plus R2. So this will be the expressions for the Anderson's bridge. So bridge balance condition, as I told you already, based on the bridge balance condition, the current balance I1 is equal to I3, and the expression becomes as shown in the figure, Z1, Z4 is equal to Z2 into Z3. The key formulas here we are deriving is L is equal to R2, R into R2 plus R4 divided by R2 into R3 minus C, and resistance R is equal to R1, R4 divided by R3, and the null deflection should show. So after null deflection, we are taking this as the value. So this is the balance condition. So what are the various applications of Anderson's bridge? It is used based on this. We are using it in the coil inductance measurement, transformer winding testing, high quality Q inductor characterization. The key advantages of using this Anderson's bridge is a precise laboratory measurement, self-inductance with series resistance, suitable for small inductors. and used in the labs and control systems. So the practical setup we show in the lab, the required equipment is the bridge panel and the various supply systems connected across the various supply across an unknown value of capacitance and the variable resistance are there. Adjust and find the value, group the readings. Coming to the summary, final part of the video, we are just going to have the inductance measurement. So we have seen various types of inductance measurement, and this is going to be the Anderson switch, where we measure the inductance with the help of the capacitance. We are going to get the formula using the bridge balance condition, and we'll be deriving the expression for inductance. Thank you. I hope you understand. Let's meet in another video with a different topic. Thank you.